Okay, the second half of our lesson is on the laws of reflection. So, the first part of the laws of reflection states that the angle of incidence is always going to be equal to the angle of reflection. So, whatever angle of incidence you have, for example, let's say it's, 47 degrees, that means that the angle that that same light ray bounces off of that surface will also be 47 degrees. So if you know the angle of incidence, you automatically know the angle of reflection and vice versa. The second part states that the incident ray, the reflected ray, and the normal all lie in the same plane. So, what would this look like? Well, if I was drawing a mirror, and then I was drawing my normal line 90 degrees from that mirror, and then I had my incident ray coming in, and I had my reflected ray bouncing off. Okay. It would mean that the angle of incidence, A of I, let's say in this case it was 27 degrees, that would mean my angle of reflection is also 27 degrees. This is the most important part of the law of reflection, that you understand that the angle of incidence is always equal to the angle of reflection. If you know one, you automatically know the other. And you'll notice that the normal line, the incident ray, the reflected ray, and the mirror are all in the same plane. Okay, now what do you think about the surfaces of objects and how it affects reflection? Do you think a flat surface reflects light rays differently than a bumpy surface might? Specular reflection refers to the reflection of light off of a smooth, shiny surface. So we have been talking about reflection off of a plane mirror. Those plane mirrors are smooth and shiny, which means that the incident ray and the reflected ray are always going to be entering and leaving the reflective surface at the same angle, which produces a really clear and uniform image. Everything lines up and it's actually quite beautiful. Think of really still water. If you've ever seen the reflection of trees off of really still water, they'll produce like a mirror image of the forestry behind it. That's because the water is smooth. It's not moving, which means the incident rays and the reflected rays are all bouncing off at the same angle. Disco balls, same idea. They have a plane mirror underneath the actual ball. That's what allows for the reflection of the light, and you're getting specular diffusion. Diffuse reflection, on the other hand, is the reflection of light off of an irregular or dull surface, so something with a lot of bumps. And so what ends up happening is, while yes, the incident rays are all coming in at the same angle, because of the bumps in the surface, they're all going to be reflected in different directions. Examples of this include reflection off of a sheet of paper or a crumpled piece of aluminum foil. You can try this at home. Or if you've ever looked at a reflection on water that's not still, so water with waves or ripples, you'll see an example of diffuse reflection. People with dyslexia often complain about the glare off of white paper. This is because too much light is actually being reflected. So what ends up happening is the image that their brain perceives is not clear, so it makes it very difficult to read. A solution for this can be using colored filters or glasses that can actually reduce the glare. Okay, so this brings us to the end of the second part of our lesson. The key takeaway here is that the angle of incidence is always equal to the angle of reflection in plane mirrors. This is the law of reflection, so if you know one, you automatically know the other. Email me with any questions.